Hello once again, welcome back to my channel. Today we shall be looking at trigonometry, and building the concept of trigonometry is very easy in our trigonometric lessons. So this video is geared towards reviewing the concept of trigonometry. Stay tuned till the end and you will not be found wanting. Alright, let's take our objective. Objective number 1. The 6 trigonometric functions, we shall be looking at them. We shall also be looking at the Cartesian coordinate and quadrant in relation to the trig functions. We shall also be looking at angle measurements in degrees and radians. That is, how to change degrees to radians and radians to degrees. And we shall also be looking at the Patagonian Theory. Let's take the first one, the 6 trigonometric functions. When we talk about trigonometry, it actually means triangles measure. So then we shall actually be using angles to discuss the concept of trigonometry. Let's consider the right angle triangle below. If I have this as a right angle triangle, the red line is the hypotenuse. The white line is the opposite and the adjacent. These names are given with respect to the angle over there, which is represented by a Greek letter known as the theta. So this is theta. So these angles or length are with respect to the angle over here. So the part directly opposite is this line, which we label as opposite, certain as OPP. Then the adjacent, the side just to the angle, and the hypotenuse is the longer side. Now the 6 trig ratios are the relationship between the length of these 3 sides: the hypotenuse, the opposite, and the adjacent. Now, these relationships exist when we pick the opposite, OPP. It has its division. So we pick opposite divided by the other 2 sides. Opposite divided by the other 2 sides, hypotenuse and the adjacent. Then when you pick the adjacent, you divide by the other 2 sides, opposite and then the hypotenuse. The last one is the hypotenuse. So you pick the hypotenuse, divide by the other 2 sides. And these are the 6 basic trigonometric functions. We have 1, 2, 3, 4, 5, 6. These are the 6 basic trigonometric functions, and we shall be looking more into it. Please don't forget to like, share, and more to the point, subscribe to the channel so you'll not be left out when I'm releasing any new video. If you have not taken your trigonometric lesson yet, this video will help you to know the basics and the concept in trigonometry before you dive into the lesson. Alright, so the trig ratios are basically written as sine, cosine, tangent, cotangent, secant, and cosecant. All these are related to these sides of the triangle we have outlined. Example, we know sine can be found inside here, cosine can be found inside here, tangent can be found inside here, and we will look into it more details. Now, these trig ratios are written in their short forms as sine, cos, tan, cot, sec, and cosec. Let's look at this mnemonic, which will help us to easily remember what we are learning. You don't have to memorize it, you just need to understand it. So SOHCAHTOA is a mnemonic which stands for opposite over adjacent. So the S is sine, O is the opposite, and then the hypotenuse is the H. Then we talk about the car, which is C cos. Adjacent is the A, and the hypotenuse is H. Then the tower, tan. O is opposite and the adjacent is the A. So this mnemonic is going to help us more to comprehend what we are looking at. So when you look at this, it actually depicts the division we did in the earlier part of this video, where we pick each angle. So when I pick this length, I divide by these two lengths. When I pick opposite, I divide by adjacent and divide by hypotenuse. Now go back and look into it. Which of these divisions corresponds to this? Example, when I pick opposite divides hypotenuse, you realize that we got sine. When we pick the adjacent and divide by the opposite, we got cos. When we pick the opposite divided by the adjacent, we get tan. Find out the rest. Go back to the video and just review it by yourself. Now we want to take at least one example to see how we can find sine theta, cos theta, and then tan theta. Let's take an example. Assuming that the adjacent side, the length is 4 centimeters, and the opposite side of this theta is 3 centimeters, and the hypotenuse, which is the longer side in the bar, and the part opposite to the right angle side is 5 centimeters. Let's find sine theta, cos theta, and then tan theta. Sine theta, we know, is opposite over hypotenuse, so 5 over 3. So 3 over 5, which is equal to 0.6. Cos, we know, is adjacent over hypotenuse, which is 4 over 5 centimeters. And the answer is 0.8. Therefore, cos theta is equal to 0.8 when they ask you for that question. Then we have tan theta to be equal to opposite over adjacent. Opposite is 3 centimeters and the adjacent is 4 centimeters. When you break it down, you are going to get 0.75 as the result for tan theta. Now, the other three trig ratios are basically the reciprocal of these three basic trig ratios, which are the sine, cosine, and the tangent. The cosec and then the cosecant, and that of the sec, and that of the last one, the three of them, they are the, what do you call it, the reciprocal of these three basic ones. So we have the sine, we know it is opposite over hypotenuse, all right? Then the reciprocal of sine is cosine, so cosecant. So cosecant is hypotenuse over opposite. It is very easy to take the reciprocal of any number. We know the reciprocal of the AB is the same as BA. The reciprocal of AB is BA. Just overside it. Bring the one down to the top and bring the numerator to the denominator. Then when we look at cos theta is adjacent over hypotenuse. Its corresponding reciprocal is sec. So secant is hypotenuse over adjacent. So just the reciprocal of this one. The reciprocal of this one. So hypotenuse over adjacent. Let's look at the last one. Tan theta is opposite over adjacent, which is corresponding to cot. That is cotangent. Adjacent over hypotenuse. This is reciprocal of it. Okay. So when we know these basic three ratios, we will be able to get the rest. So you don't need to memorize everything. Just know SOHCAHTOA and you get this. Now, one thing we can easily identify is that we need to know their correspondence. You see that this is sine, cosine, cosecant. Are you getting that? So the opposite, cosine, co-equal. If the sine, the co, they are more or less the same, is cosecant. So sine goes with cosecant. The reciprocal is cosecant. Tan is cot. That's cotangent. Tan, cotangent. Cotangent. Just keep it in your mind with this. Tan goes with cotangent. Sine goes with cosine, cosecant. Cosine, cosecant. Alright? When you come to the cost, definitely we cannot use co again. So therefore we just use secant. And this, if you're able to identify the first two, then you know that the remaining secant is for the cost. And you are good to go. Alright. Want to know this? Take note of this very well. The trigonometric functions are properties of angles and not triangles. They are properties of angles. They are properties of angles and not triangles. Yes, we can find angles in many plane figures. In 4-sided plane figure, 5-sided plane figure, 6-sided plane figure, they all have angles. And they can all be related to the properties of the trig. Now, it doesn't mean that because we have used right angle, triangle for this example, it means that we are talking about triangle. It is angles that we are talking about. Take note of that. So the properties of the trigonometric functions are about angles. Now, also know that the trig functions are unitless. And also know that the trig functions are written and read as sine theta and not sine in the bracket theta. So look at the difference here. There's no bracket in here. There's no bracket here. Alright? The last one I want to note is that we'll be squaring trigonometric very soon. And when you square it, read it as sine square theta, but not sine theta square. Note this very well. Read it as sine theta and not sine theta square. Very well noted. Now the next objective, we look at the Cartesian coordinate and the quadrant. This gives us the x and y plane, with the y and the x, known as the Cartesian plane. To the right is positive of x, and to the left of x is the negative. To the up of y is positive, and to the down is negative. Now, we can plot a point inside this quadrant, the first quadrant. To plot a point, we need the y coordinate and we need the x coordinate. So if the x is 4 and the y is 3, we can get a point at where they meet. So you trace 4 centimeters to your right, positive 4, and then 3 units up, that's positive 3, the y axis, and you plot the point over there. Now this comes your point. In this quadrant, we know that y is positive and x is also positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both are negatives. And in the fourth quadrant, x is positive and y is negative. Now the third objective is that the angle measurement in degrees and radians. Take note of this very well. Take your time and go through it, and you will not regret. Degrees to radians. Every circle we know is made up of a complete radii of 2 pi radii, and the total degree of a circle or a point is 360, which is equivalent to 2 pi in radii. So 1 radian is a 1 ray. Then when we have a complete ray, then we say that it is 2 pi r, the circumference of a circle. Alright. Now to change a degree to radian, we just do a simple mathematical computations. Now we start from our reading in the eastern side of the Cartesian plane drawn in this circle. So we start from here, labeling as 0 degree, 90 degree, 180 degree, and then 270 degree. That is when you break the whole circle into 2 equal divisions. So you get the 4 quadrants inside there. Okay, now here is 0 degree, 90 degree, 180 degree, and then 270 degree, back to 360 degree. From 0 degree to 90 degree can also be further broken into 2. So I have equally, we have 90 divided 2, we have 45, which is this 45 over here. Now to get the radians part of this degree 45, we take 45 divided by the total angle of the circle, which is 360. So 45 divides 360 multiplied by the total radian, which is 2 pi. Okay, so when you pick this, let's divide and see what we have. 45 degree divides 360 degree, then this is multiplied by 2 pi, and let's see our result. The result here is 1/4 pi, that is pi over 4, correspondence with 45. You can do the same for 30, you can do the same for 60. When you do it that way very well, you realize that at the point of 0 degree, the radians here is also 0. 30 degree is 30 divided by 360 multiplied by 2 pi, which is 1/6 pi. Are you getting that? So this is how you can convert degrees to radians. Just pick the respective angle. If it's not here, if they have given you any angle at all, let's say 125.6, you take 125.6, that's the degree given to you. So just take this degree, divide by 360 and multiply it by 2 pi r, 2 pi, and I'm going to get this as a result. So breaking it down, you get 2.1921 pi. So that is in the radians form. So don't worry to chew it. You don't have to chew this to know that 90 is equal to pi over 2, to know that 60 is equal to pi over 3. Just know that you pick the respective angle, divide by 360, multiply by 2 pi, and you're going to get your answer straight away. Please don't forget to subscribe. I beg. Subscribe and promote the channel for me. Let's look at the fourth objective, the Patagonian Theory. Now, we shall consider any right angle triangle to explain the Patagonian Theorem. So the sign here means it is right angle triangle. Then the angle theta is given. I have the part A, B, and then C. C is the hypotenuse we know. B, the part directly opposite to the angle theta is B, so that is opposite. A is the adjacent. Now there is a theorem over there. According to the Patagonian theorem, A squared plus B squared is equal to C squared. The square of the hypotenuse is equal to the sum of the squares of the other two sides, which is this. Where we know the C, like I said, is the hypotenuse. Now let's consider the same one with respect to the trig functions. We know, like I said, here is opposite, and here is what? Hypotenuse, and then the adjacent, which means that adjacent square plus opposite square is equal to the hypotenuse square. Driving that into a unit circle, we're taking that into a unit circle. We have cos, which is the x coordinate, and the sine as the y coordinate. We got the coordinate as cos theta sine theta. Now the hypotenuse is 1 because it's a unit circle. And the unit circle is a circle making a radius of 1 unit. The radius is 1 unit. That's why it's called a unit circle. Now we can apply the properties we have learned earlier on to get some other properties over here, 3 properties over here. Now, we know that the sum of the squares of this side is equal to this square of the hypotenuse. So, sine square plus cos square is equal to 1 square, which is the same as 1. So, this is one of the common and the fundamental trig identities we need to know. We can also note that tan, as we look, tan is opposite over adjacent. Opposite over adjacent. It means that sin theta over cos theta. Sin theta over cos theta. That is tan. You can use the same diagram to elaborate on a lot of these identities. So when you want to get tan, we know tan is equal to sine over theta. I can make cos the subject by multiplying through by cos, and then multiply here to by cos. So cos will cancel the cos, and then I will now divide it by tan again. So cos is equal to sine over tan, as simple as that. Just make sine to the subject and you are good to go. 1 over tan. So if you take 1 over tan, which is sine over cos. So 1 over tan is cotangent. So it means that 1 over tan is the same as cos over sine. So it means cot is equal to cos over sine. Just apply them and you are good to go. Alright? Let's look at some other common trigonometric formulas or identities. So the variation on the Pythagoras theorem, the one we just look at the Pythagoras theorem, we realize that it's sine square A, which is there we represent as theta, and then cos square A is equal to 1. We have looked at that. Tan square A plus 1 is equal to sec square A, which is same as tan square A minus sec square A is equal to -1. So you can decide to also say that sec square A minus tan square A is equal to +1. Just like that. And you are good to go. Then half angles. Take your time to go through these identities. Hope this video has helped you very well. Don't forget to like and subscribe. More to the point, hit the notification button so that you'll not be left out when I release any other new video. Please stay tuned in my channel. Thank you very much.